Hi guys, today we're going to talk about just the basics of matrices, and a matrix is just a way to organize data, and it's used in math a lot of times, but the basic idea is just to organize like a lot of different informations. So it's nice to know that systems of equations has a way to, when you get lots of equations, it's just a way of organizing that. So we're going to talk a lot about reduced row or row echelon form and then reduced row echelon form. That will be in tomorrow's lesson. But today we're just going to focus on the basics of matrices. So what is a matrix? This is, just a rectangular array of elements written in brackets. So it's going to look like this. Rows, this is what you need to know. These are rows. And then these are columns. And the way I think about it is think about like a column in like a house or a building or something like that. You always see them go in a vertical direction. So that's what these are. These are going to be our columns right here. You need to make sure that you understand that it is named by, it says the order of a matrix is written as a number of rows times a number of columns. So this, for instance, is a 2 by 3 matrix. So it has 2 rows and 3 columns. So the next question, how many rows does a matrix contain? 2. How many columns does a matrix contain? 3. What is the order? Okay, rows by column, so it'd be a 2 by 3. The next question is, what does the element A23 represent? Okay, so it's not, don't look at it as 23. It tells us that it's in row 2, column 3. So in your practice today, it's going to reference different numbers. So you need to know that the first number is the row and the second number is the column. So I'm going to say row 2, column 3. So this is specifically designed for systems of equations problem. You'll either see a solid line or sometimes it's like a dotted. It's just the way the publisher wants to write it. There's no rhyme or reason to it. So an augmented matrix will transform this look into this. So notice like this is these are our x variables, our y variables, and then our constant or an answer. So I have like, if I were to read this, like 3x plus 2y equals 5. 4x minus 7y equals 9. So I know you can see that here. On your test, you're going to have to go back and forth. And in your practice today, you're going to know, or you're going to need to know how to do this, go from this direction here, and from this direction, or from this information to this information. Okay, so we have this situation where we have a, notice that we have 3 variables here. So I know that I'm going to have, even though you're not going to, let's go back. Notice you don't have to list it as x, y, constant. We're going to kind of start off that way, even though know that like in a book you won't see that. So we have our x column. I'm going to do this here. Our y column, our z column, line, and then our constant column. So it's going to look like that. So the weird thing about this is there's no z, so it's going to be 3, 1, 0, 2. So 3x plus 1y plus 0, z equals 2. So the next one, negative 4, 3, 1, and 4. And then the last one is 2, 5, 1, 0. Now let's go backwards. We have this matrix that we need to change into a system of equations. So I have, notice that there's only 2 columns here, so I'm going to assume that it's 3x minus 7y equals negative 4, and 11x plus 2y equals negative 1. and then I could solve that or whatever we needed to do from there. Okay, row echelon form. We are just going to become comfortable with the concept today, and we're not going to do a whole lot with it. So the main diagonal of the matrix is the elements that have the same row and same column position. So think about this, just this aspect here. So A11 would be here, A22 would be here, A33 would be here. So it's making that diagonal there. That's what this sentence is saying. If all the elements below the main diagonal are zeros and all the elements in the main diagonal are 1, then the matrix is said to be in row echelon form. Okay, so now we're going to take these and imagine that they're all 1s here. And what this says is that the elements below the main diagonal have to be zeros. So it looks something like that. If all the elements above the main diagonal are 0, then it's said to be in reduced row echelon form. So now I'm starting to add zeros up here. So it would look something like that. So in this one, I want you to maybe push pause and decide whether or not these are in row echelon form, reduced echelon form, or neither. Okay, so this one is reduced row echelon form. So I'm going to say RREF, because notice the diagonals, and not only do I have a 0 below, but I have a 0 above, and then my answer. So as we carry on with this, this will be like our final answer, and we would read this as x equals 3, y equals 6. So if that doesn't make sense right now, that's okay. That's going to come in tomorrow's lesson, but I just wanted to give you a heads up of what that meant. This one is in just row echelon form, and this is why. We have a 0 underneath the 1, but above this one, we have a number. So that's okay. It still follows a rule for row echelon form, but it's just not reduced. This one is neither. And, oops, sorry, I can't spell neither. It's neither because of this guy right here. So if we went, like 1, 1, and even if this was a 1, it would be in row echelon form. But because that's a 5, it kind of messes things up. Okay, this one is also neither because we have this 1, but we have a 2 here. So that makes it not in a row echelon form at all. This one is actually row echelon form because we have the 0 underneath and we have the 1, and it's not reduced because we have this 3 up here. But so far this is okay for row echelon form. And this one is neither because of this row right here. So it should go 1, 1, 1, and that row kind of messes it up. Okay, so we're going to do some operations with this. So let's just kind of back up before we get into this part, and let's talk about adding matrices. So if I had, let's say like 1, 2, 3, 4, plus 5, 6, 7, 8. Feel comfortable with just like adding. So this number plus this number is going to equal this number. This number plus this number. 3 plus 7 is 10, and 4 plus 8 is 12. So at its basic level, that is just adding matrices. If I wanted to multiply a matrices, so let's pretend like I wanted to multiply the answer by 2. You would just take that 2 and kind of distribute it to everything. So instead of 6, 8, 10, 12, it would be 12 right here, and then 16, 20, 24, like that. Okay, we are going to get into this kind of stuff over here. And I think the best way to kind of explain this besides me just reading it, is to really get into these problems. So this stands for row 3. So what I want to do is I want to take row 3 and multiply it by 1/2 and make it our new row 3. So that's what that's saying. So I'm going to take this and I'm going to multiply everything by 1/2. So pretty much I'm just dividing by 2. So the look of my new matrices, these first 2 rows are going to be the exact same, but the last one is going to be 0, 1, -2, 6. So it looks like that. Okay, let's try problem number 2, or that middle one. So this one, what this one says is I'm going to multiply row 1 by 3 and then add it to row 2. So we're doing a lot of stuff, and that's going to be our new row 2. So our row 1 is going to stay the exact same, as well as our row 3. So even though we changed it over here, we're going to start new on this one. So notice that this row is the same and this row is the same. Okay, so for this row, what we're going to do is I'm going to multiply everything 3 by 3 here. So I get 3, -6, 3, and 9. And in the same step, I'm going to add these 2 together. So these 2 together. So I have 3 minus 3 is 0. -6 plus 0 is -6. 3 plus -1 is 2. And then 9 minus 5, or plus -5, however you want to say it, is 4. So it looks like that. Okay, and so this bottom, or this last one, what it's doing is it's switching row 2 and row 3. So row 1 is going to be the same, but row 2 is now row 3, and row 3 is now row 2. So all 3 of these operations is like what you're going to be doing to solve systems of equations in this new way, this new augmented matrix. We're going to do that to get the answer to this. So this is a very new technique, a very different way of solving systems of equations. Okay, so I want you to look at this last one. So our goal is to get from here to here using this kind of setup here. So just kind of look and see, notice that first one, that first row, I didn't do anything to the first row. But the second row, I did several things to. So maybe try to push pause and get your mind wrapped around what's going on, and then I will tell you the answer. If you guys hear music in the background, that is my son playing on his guitar. Okay, so what I saw is that this was probably multiplied by -3 and then subtracted to get this to 0. That was the first thing that I saw. So let's test it out and see. So if I multiply everything through by -3, I get -3, +3, +3. Okay, so now I'm just going to start a new matrix so I can wrap my mind around this. Okay, now I'm going to subtract those, and I get 0, 5, oh, that's it, 15. Okay, so that's what we did. So what we did is we multiplied everything in row 1 by 3, and then we added it to row 2 for it to become our new row 2. So that's our answer. This is tough. It's going to take a lot of practice, but that's what we're going to really focus on tomorrow. So we just got done with the lesson.